Hey, AP Statistics. So welcome to the second section of 9.1, where we're starting to get into the big ideas of these significance tests, and then we'll get into the specific details of calculating them in 9.2 and 9.3. So in this section, we're going to look at, this is actually one of the trickier concepts from significance tests that people get confused, and part of it's that it's got these terrible names. We're going to talk about type 1 and type 2 errors. Just really terrible names, not descriptive at all, and you just kind of have to remember which one is which. Sorry, if it were me, I would have named them different things, but this is what they are. So when we draw a conclusion from a significance test, we make that decision to reject the null or fail to reject and so on. We hope our conclusion will be correct, but sometimes it will be wrong. We might make the wrong decision, and it's not our fault, but based on our data, it was leading us a particular direction. And so those two types of error, type 1 and type 2. A type 1 error occurs if a test rejects the null hypothesis when the null hypothesis is true. So if the null hypothesis is true, but we get a sample result that is so far away that just by chance we happen to get unlucky and that we find convincing evidence for the alternative and we reject that null, if that happens by accident, we call that a type 1 error. And then type 2 is kind of the opposite. If we do reject the null, but we shouldn't have, right? So this is kind of in so many words. Type 2 error, if a test fails to reject the null hypothesis when the alternative hypothesis is true, that is the test does not find convincing evidence of the alternative when it really, we should have gotten those convincing results. And so there's a little chart here to help us with this. And so if the null hypothesis is true and we reject it, that's a mistake. That's a type 1 error. If the null hypothesis is true and we fail to reject it, we didn't find evidence against it, that's correct. Alternatively, if the alternative hypothesis is true, we should reject, and we do reject, well, that's also correct. However, if the alternative hypothesis is true, but we fail to reject, we fail to find significant evidence for the alternative, that is a type 2 error. So we need to be able to identify both of those, think about what they are, and think about how bad they are. That's a really important piece of this. So an example here. A potato chip producer and its main supplier agree that each shipment of potatoes must meet certain quality standards. If the producer determines that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load of potatoes from the supplier. Otherwise, the entire truck load will be used to make potato chips. To make the decision, the supervisor will inspect a random sample of 500 potatoes from the shipment. The producer will then perform a test at alpha level 5%, 0.05, significance level, and this is their null hypothesis. So their null hypothesis is that they're at an 8% blemish rate, and then the alternative is that that's more than 8%. And so that's really what we're trying to see. Are there more than 8% blemishes? We don't want it to be the case, but that's what we're testing for. Testing to see if there are more than 8% blemished. Where P is the true proportion of potatoes with blemishes in a given truckload. And so describe what a type 1 and type 2 error would be in this setting and give a possible consequence of each. So the type 1 is if the null is true. So if there really are 8% blemished, but we reject it and we find convincing evidence that more than 8% of them are blemished, when the proportion really is 0.08, that is the type 1 error. We just happen to accidentally pull with randomness, right? There's chance involved. With randomness, we just get unlucky and get some blemished potatoes, too many blemished potatoes, and we reject when we shouldn't have, right? The actual null hypothesis is true. So what's the consequence? Well, we reject a good batch. The potato chip producer sends away the truckload of acceptable potatoes, wasting time and depriving the supplier of money. So could be some bad feelings, some hurt feelings as well. All right, so then what about the type 2 error in this setting? So the type 2 is the opposite. Not that the null hypothesis is true, but the alternative is true. We should reject, but we fail to reject. So the producer does not find convincing evidence that more than 8% of the potatoes in the shipment have blemishes when the true proportion is greater than 8%. So the consequence here is we actually got a bad batch, but we didn't realize it. We didn't find significant evidence of that. We happened to get too many good potatoes mixed in, even though really more than 8% of them are bad. we didn't find convincing evidence. So more potato chips are made with blemished potatoes, which may upset customers and lead to decreased sales. And so then, you got to go back and think about, well, which one of those errors is worse? And that can help inform what type of significance level you want to use, because it relates to that significance level. So our most common significance levels are 5%, 1%, and 10%. So which one of these is the best choice given for a given significance test? Well, that depends on whether a type 1 or type 2 error is more serious. So a type 1 error probability, the probability of making a type 1 error in a significance test is equal to the significance level. So that seems kind of weird, but if the null hypothesis is true, and when we get a result that would only happen, say, 5% of the time, or 1% of the time, or 10% of the time, if we get that result, that's going to cause us to reject. Well, how often does that happen? It happens 5% of the time, or 1%, or 10% of the time. They actually call type 1 error, sometimes we refer to this as alpha error. It is exactly equal to your significance level. So if a type 1 error is really bad, if rejecting a true null hypothesis results in some really bad outcome, go with 1%. If the type 1 error isn't too bad, then we can go with 10%. And in fact, then, how does it relate to type 2 error? We'll see. So we can decrease the probability of making a type 1 error in a significance test by using a smaller significance level. But there's a trade-off between type 1 error and type 2 error. As one increases, the other decreases. And so if we make it more difficult to reject the null hypothesis by decreasing alpha, so we say we're going to go down to 1%, we're going to make it so we need really strong evidence to reject, well, that's going to make it harder for us to reject when we should reject. And so when the alternative hypothesis is true, it makes it it's less likely that we will find convincing evidence. So that's the downside of this. And so be thinking about that you pretty much where you set your alpha level is going to affect both of those error rates. Of course, another thing we can do is increase our sample size, which helps make everything better, of course. But yeah, be thinking about that. Which error is worse can help inform which type of significance level, alpha level to go with. Usually, a lot of times, though, 5% is a nice kind of balance in between the two.